Hi, and welcome to the 7th video in the Glacier Image Velocimetry, or GIV, toolbox video tutorial series. My name's Max van Veek de Vries, and in this video, I'm going to be talking through a little bit of GIV's source code. And we're gonna run the code, and we're going to have a look at exactly what it does. So in order to be able to do this properly, we've got to jump to MATLAB, just close all these extra windows that we don't need. Jump to MATLAB, and we can read all the code in MATLAB. The first code file that you want to be aware of is called GIV GUI initialize. You're going to be familiar with this already if you've been launching the code. And primarily, this function contains code that builds the user interface, but it also launches all the other functions within the toolbox. So that's useful to know. In addition, all other files are contained within this functions folder. There's a primary code file called GIV GUI main here, which we will look at in more detail in a second. This is basically a wrapper which launches all the other functions. For example, it loads the images, it crops the images to a mask, it actually performs the feature tracking. All of this is launched from this GIV GUI main function. And you can see these little red marks. I've put some pause markers in this. When we run the code in a moment, we'll be able to see exactly how it works. For now, just to show you where the rest of the code is located, image preprocessing and filters contains the image processing functions that are applied prior to the feature tracking. Particularly have a look in crop mask and image prefilter.m functions to see more about that. The feature tracking itself is performed in the image cross-correlation folder. This code is fairly complex, I will say. If you're not familiar with reading through MATLAB, it may be a challenge to get through. But GIV core contains most of the code here, and launches GIV track and GIV track multi, which are the single and multi-pass feature tracking solvers. Then we have some post-processing functions located within this folder, particularly filter, which filters individual velocity maps based on the global data set, and im to month, which converts individual velocity maps into a monthly time series. There is a folder called other, which contains some utilities. There's a folder called nan-circ-stat, which contains a circular statistics toolbox, which is used for flow directions. Don't need to worry too much about either of those. And there's a saving folder, which contains a function which produces the plots and saves the data files and backs them up as the code is running. It also contains colorblind friendly color maps from Fabio Crameri and Calabria, which are used for producing the plots in GIV. Okay, so to see better how it all works and exactly what files are launched, I'm gonna press run, and you'll see that I've set some pause markers within this GIV GUI main file. Here it has paused it before running any of the code. And if we have a look in our MATLAB workspace right here, you'll see that there's only one file there, a MATLAB structural array called inputs. This has just saved all of the parameter options from the graphical user interface in one inputs folder. For example, we can see that the name is video 7. The folder is the folder we selected, and so on. this inputs folder is used to feed this information into the different functions from here on in. So first, this load T-series function is going to actually load the images. So it's going to take a second for that to happen. When that's completed, we can have a look at the files that's created. I'm going to pause the recording for a second. Okay. So now we've paused it after loading the time series and before cropping the images. And we can see that we have a new file in the MATLAB workspace called images. This is the main data file in which the results are going to be accumulated, but it also saves the images themselves. And we can see here, prior to being cropped to mask, they're saved as 3-band images. And we can plot them if we want to have a look. If we want to have a look what they look like. So here, if I just check it's images 2, 3. And I'll use imshow just to plot it. And it's a fairly large image, so that might take a second, but I see what's happened. It's plotted it in the thumbnail of the, let me close those so it will plot it properly. Here we go, yeah. So it's loaded the images of Perito Moreno into the MATLAB workspace now. So let's go and press run again. What it's doing currently is cropping these images to the mask, which will also just take a second. Okay, so the images have now been cropped to the mask, so to speak, and pre-processed, and they're now going to look quite different to what they did before. And what you'll also notice is that we've launched a parallel pool because we're actually running this in parallel. So you can launch a parallel pool prior to launching GIV, if you like, and then you can choose the number of workers, which is the number of cores from your computer, which you want to use. Here I'm going to use 6, which is all of the cores on my laptop. And I'm going to plot this. I'm not going to use imshow. I'm going to use image scale right now, just to show the difference between the image before and the image now. You can see for one thing, it's been flipped, but secondly, it's had an orientation filter applied to it, which brings out a lot of the features. And one of the primary advantages of it would be that it reduces the contrasts between images with different illuminations, images with different degree of shadowing or degree of cloud cover. It removes all of that by removing the pixel intensity values and preserving only the pixel orientations in a certain form. So you can still see the crevasse fields over here, but now the illumination variations have been removed. So let's run to the next stage. This one's going to be pretty quick. The save raw array is just going to save a backup of this image, and we can see that we had a brief message displayed which said images loaded and cropped to mask. That means the first stage of the code has been completed, and we're now ready to actually perform the feature tracking. So the feature tracking is now running. If the feature tracking is going to take a long time. You will get messages that will be popping up telling you how long is remaining. Every time it calculates a velocity map, it stores the time that your computer took to calculate that and uses that to estimate how much longer it's going to take to compute the entire data set. It will allow you to know how much longer your computer is going to be running through GIV. And that is now completed. Here we can see that it's run it all in one stage there. Velocity pairs calculated, filtering and saving entire data set. So now it has calculated all of the velocity maps. The velocity maps now exist. The individual velocity maps may or may not be very good at this stage, but they are now going to be filtered based on the entire data set. So let me just open one of them. Let me open 2.7 in images, which will be one of the velocity maps. If one was correctly calculated for those dates. Right there, it's going to plotted it. Let's try 3.7. Yeah. So here we can see that we've got a raw velocity map. We can actually see that it's not too bad here. We got the high velocity zone in the center. It's flipped upside down, which is something we'll deal with later in the code. We got low velocities over the bedrock and at the margins of the glacier. We got a bit of noise over in the lake where there's probably some icebergs that are moving around and that are confusing the feature tracking algorithm. And if we click here, we can see approximately what the velocity is. So 750 meters per year sounds about correct. So this hasn't done too badly. Let me just drag this here so I can close it. So you can see we've now got velocity maps. What we're going to do is we're going to filter them based on the entire data set to create median velocity maps. See that was already completed. That happened very quickly. So now we've got an additional file called images stack, which contains the statistics. So if we plot images, let's plot the mean velocity map from images stack. If I open this, you can see that there are two columns. The first column just contains the name describing what that is, and the second column contains the actual data. So let's plot the median velocity. So the second column and the seventh row. So this will be the 7, 2. So if we plot that now, we see that this is the median velocity averaged across all, and we can see that it's a lot smoother, particularly over the glacier itself, than the individual velocity map. And we haven't got a large data set here. We've only got 4 images. So bear in mind that if you have 100 images, this can be considerably improved. Now let's run this again, and we'll get, we have now calculated monthly average velocities. In this case, they're not going to be very meaningful. We haven't got a large enough data set. But if you look here, we've now created a monthly averages data array as well. It will create one column for each month. Sorry, one row for each month here, the January and February 2020. Each one is only going to be constituted of a couple of velocity maps here, so they're not very meaningful. But just to show you how that works. And finally, the last step is going to be to save the images. And as I click this, I'm actually going to go and have a look in the images folder itself. So here I'm going to go in, open the folder. It was called Preprocessing. this is where we save the images. So you can see here we got our 4 images, our mask and our save images. And as we ran GIV, it's created a new folder named results here. Now in here, in the results folder, for each name that we call a run, it's going to create a new folder under that. So here we called it video 7. So I'm going to click into there. And we can see as it's currently running, so it's actively going to be creating files in here right now. So you can see that there's one called initial data backup that will have been created previously as GIV was running. And it's now got MATLAB data files, data figures images, which are going to be PNG plots of the data. And it's currently running. But what it's going to create in here as well is georeferenced geotiffs. It will take maybe a few seconds to actually produce those because it has to plot a number of different files. But that is essentially all there is to GIV. In the next video, we're going to have a look back at these outputs and look at the details of them. So please tune in for that. For now, I hope this was useful. Thanks.